This module provides an introduction to the CFM56 power plant. Specific modules will be provided to train the various components that are introduced in this module. The high bypass engines are of twin spool design with an N1 and N2 rotor. The N2 rotor is connected to the accessory gearbox through a horizontal high-pressure rotor drive shaft. The accessory gearbox allows the engine starter to crank the N2 rotor during engine start. After the engine start, the N2 rotor drives the accessory gearbox to operate the IDG, hydraulic pump, and other driven components. The annular combustion chamber is equipped with 2 igniters and 20 fuel nozzles. The use of igniter A or igniter B is normally determined automatically, but under certain conditions, both igniters can fire simultaneously. The airflow moves through the fan, the low and high pressure compressors to the combustion chamber, and then exhausts through the high and low pressure turbines to provide the driving force for the fan and compressors as well as some forward thrust. The fan airflow provides the majority of the engine thrust. Each engine is equipped with thrust reversers that can only deploy on the ground. The thrust reversers are operated hydraulically. These reversers incorporate the use of blocker doors to deflect the normal flow of fan air and therefore cause the fan airflow to be reversed. During reverse thrust, the primary airflow continues to flow normally. The FADEC, or Full Authority Digital Engine Control System, provides engine management for all functions of the engine. The FADEC may also be referred to as the Engine Control Unit, or ECU. The FADEC is of independent 2-channel design to improve reliability. This design allows for one channel to be active while the other remains in standby. Channel switching is automatic and occurs when the active channel fails. The Engine Interface Unit, or EIU, transmits the necessary data to the FADEC. This diagram gives an overview of the relationship of the EIU, the FADEC, and other engine features. Engine thrust levers are never positioned automatically but are moved manually by the pilot. The thrust levers allow conventional thrust control when the aircraft is on the ground, but are normally set to a sector detent for flight. After takeoff, the pilot moves the thrust levers to an appropriate sector detent, such as climb, and thrust is then automatically controlled by the auto thrust system. The auto thrust system may be disconnected by use of either of the auto thrust instinctive disconnect push buttons. To select reverse thrust, the reverse latching levers are raised. This action overrides the reverse stop at the forward idle position and allows the throttles to be pulled aft to select reverse thrust. After reverse thrust operations are complete, the pilot moves the thrust levers forward to the forward idle position and the reverse stop is reset. The engine fuel system provides fuel to the engine at the correct rate and pressure for combustion. Additionally, the fuel system provides recirculation fuel for cooling of the IDG when necessary. The fuel supply is controlled by the FADEC through the Fuel Metering Unit, or FMU. The engine oil system provides lubrication to the engine components. It is a self-contained system that cools, filters, and recycles the oil for continual delivery to the engine bearings and gearbox. The engine starters are pneumatically operated and are provided compressed air through the start valves. Engine bleed air is provided to the pneumatic system and to provide cooling to engine components. Additionally, the control of engine bleed air is used to enhance engine stability at various thrust levels. The normal supply of bleed air to the pneumatic system is provided by the intermediate pressure stage. If the engine is at low thrust levels and the IP air pressure is not sufficient, the high pressure stage valve opens to maintain adequate bleed air, pressure, and temperature. The ignition system is used to start the engine on the ground or to restart it when in flight. You've learned that there are 2 igniters on each engine and 2 FADEC control channels. Each FADEC channel can control both igniters. The engines can be started by an automatic start sequence or a manual start sequence. Additionally, the crew can dry crank the engine for those times when fuel and fumes need to be cleared, such as after a failed engine start on the ground. The engine mode selector is used for engine starts and to control ignition. To either side of the mode selector are the engine fire lights and the engine fault lights. The fault lights illuminate for an automatic aborted start, a start valve fault, or when there's a disagreement between the high-pressure fuel valve position and its commanded position. The fire lights are described in the engine fire protection module. The 2-position engine master switches are moved to on during engine start and moved to off to immediately shut down the engine. The manual start push buttons are used for the manual start sequence or to dry crank the engines. The upper ECAM EWD permanently displays the engine primary parameters. Other engine parameters are displayed on the lower ECAM when the engine page is displayed. The engine page displays automatically upon engine start and when takeoff power is set or when manually selected for display by the crew. Click Next to answer some questions.